Work is an important concept for this chapter because the chapter is concentrated on work and energy. And then when we mean the work, if you remember from the particle, the work of a particle was the force into distance. Okay, but in a integral form, the particle work was the force dot product with the displacement, small amount of displacement. Okay, and then for any dot product, you can show this one as f dr cosine theta. And then this is, for example, the direction of f, and this is direction of the dr. Okay, and then the theta is here. Similarly, work of a variable force in a rigid body. So we will use the same concept, that force into distance. So this one is actually differential displacement. Okay, and then this differential displacement can be shown as here as the dot product. So you can see we have a rigid body that moves from point 1 to point 2, and during that motion we have a variable force acting on the body. So from 1 to 2, so variable force F acts on the body. I have added a small real-life example. Say that you are moving in the wind. Okay, so when you move in the wind, there is a velocity of the wind, the force, let's say, drag force of the wind, which is a variable force. And then you move from one location to another location, and then you are doing work against the variable force. So let me just include this example to give an understanding. Say that this is point 1 and this is point 2, and then you are moving from point 1 to point 2. And there is a wind. So let me say that there is a wind here like this, wind like this, and then wind velocity like this. So these are wind forces by wind. Okay, and then this is variable force. You can see why it is variable, because direction changes and then magnitude changes. Direction and then magnitude both change. Okay, and then when you move from point 1 to point 2, so you have change in direction and then you have change in magnitude. Okay, but you do work against the wind. So that will be that force cosine theta and then dr integrate from 1 to 2. So from 1 to 2, that will be the work. And this wind, you can call it as a drag. Okay, and then one more thing is that what is theta, what is f, what is dr? And then in that case, you can see that. So if it is the wind, if it is your displacement, okay, that's the theta. This is theta. And this is your displacement. And this is the wind force. Okay, you go this way, the wind blows that way, and that's the theta angle that acts on you. Okay, this is F, and this is dr, and then work is F into dr cosine theta. Okay, and then that's all for the variable force. And then what if the force, and then one more example here before I move a constant force. For example, in a real life example experiment, the car crashes into this setup. And then here, as it moves inside it, there is a variable force developing against the car. Okay, that variable force, you can see how it changes with respect to position x. This is x. And then again you can find, so this is x, again you can find f dr cosine theta, and then you integrate from 1 to 2. So this is 1 and that's 2. Okay, and then again you should notice that the cosine theta, just check it here, f is that way, you move this way, and theta is 0 degrees. Okay, and the cosine theta is 1. Therefore, you will just integrate this quantity here, f into dr. Okay, dr will be dx. Okay, and then 1 will be x1, 2 will be x2. x1 and then 2 will be x2. And this is the work of a variable force. Now, when the work is constant, so you move from 1 to 2, when the work is constant, what you will do is that, if you remember the variable force case, f dr cosine theta, integrate. If it is constant, you bring it here as fc. Okay, and then it will be that fc and then dr cosine theta. Okay, and then that will be fc cosine theta, and then dr, and that will be fc cosine theta s. Okay, again you can bring the cosine theta here if it doesn't depend on the dr. Yeah, but in this case it doesn't depend, so cosine theta is constant as well. Okay, why it is constant? Because when we mean a constant force, the force is a vector quantity. Okay, constant means that the direction and the magnitude. So in our case, the direction and magnitude should be constant. It cannot change. Okay, so that's the reason that theta is constant, the f is constant. Okay, and then it moves from one location to another location. Okay, so, but this is for straight line. Okay, I should edit that. Straight line path. And then the work of a weight, so that is w into y. Okay, and this is again exactly the same as work of a particle, and that is again the w into y. As you can see, it is the same, but only difference is that we just check the g value here. Okay, g with respect to g, so change with respect to g value, the g position actually. Okay, and then as again, so we have the work of a spring for a rigid body, and then that is half, same as the work of a particle case, and then it is a spring. It is the same 1/2 ks2 squared minus 1/2 ks1 squared. And notice that s is 0, and that is the unstretched position. Okay, you can see that we covered work of a spring, we covered work of a weight, and we covered work of a constant force, work of a variable force. Okay, the next is that we will talk about the work of a couple moment. In the next recording, that's what I will talk about.